Okay.
Good, yes, please.
Okay, LSST software. So I was originally going to talk to you about world coordinate systems, but I realized that me giving a talk about two separate world coordinate systems packages, neither of which I had any hand in developing, was a little weird. And so instead, I'm going to mention that somewhat at the end because it's actually a really important thing, and you'll see why when I get there. But what I'm actually going to do is just talk to you about LSST, since Eric earlier gave a nice lightning talk about JWST and the things they're doing. LSST is also developing a lot of software. So here we go. So the fundamental LSST problem, if you want to see more numbers, there's the website. We have a 3.2 gigapixel camera. It's going to take 2 images every 30 seconds by our current baseline. That means 15 terabytes of data per night. That is 1 SDSS every 2 nights, right? We're ready. The whole southern sky, more or less twice a week. We're going to do difference imaging. So that's essentially a super duper ultra mega HD movie over 10 years. And we're going to do coads. So you take so instead of differencing the images, you add them over 10 years and you go really, really deep. And nobody knows what you're going to find when you go really, to 28 magnitude?
Well, we do, and we're scared of it.
Well, okay, we do know, because we've seen a hint of it from HSC, right, from Hyperster Prime Cam, and it's really frightening. Everything is blended. Every pixel has a galaxy in it. Seriously. Huh? HST, yeah, HST. Well, HST did that on a little thing, but like when you do it on a really big area, it's even more scary. So that's the LSST problem as a whole. UW, actually, the group that I am in here, has a very particular problem, which is the difference imaging problem. So again, 3.2 gigapixel image every 30 seconds, down to magnitude 24. That's the depth of the SDSS Stripe 82 coads every 30 seconds. We have to process it, solve for sub 1% photometry and 2-3 milliarc second astrometry, find everything that changed from the template image, and alert on the 10,000 real things that went bump in the night since you created the template. And here's the kicker. We have to do that in 60 seconds.
Challenge accepted.
Challenge accepted. That means, since we're taking an image every 30 seconds, we do that 10,000 times per night. That means 10 million real alerts per night. So if your difference imaging pipeline has an error rate of, as most of them do, of, several, a few percent even, that's like a million not real alerts. Yeah, factors of few. It's really worse than that. So you really have to crush the statistics. Okay, so that's all cool, and we have this big software pipeline to do these things. And I'm going to talk a little bit about it, but the question you maybe should be asking yourselves is this appropriate for my needs? So our pipeline, the LSST stack, is designed for automated pipeline processing of imaging data. So it's not designed for I have one image and I want to muck around with it until it's absolutely perfect, right? You have a bunch of data and you want to process it all in the same way so that it's all uniform. It is currently being used by HSC. Hyperster Prime Cam, and when I was preparing this talk yesterday, Robert Lupton gave me a link to a very recently posted paper, right, 2016-03, about a redshift 6.8 quasar and a bunch of redshift 6-ish galaxies that were discovered in HSC data using the LSST stack, or using a fork of the LSST stack, which is in the process of being merged back in. We have tools to process DECCAM, CFHC Megacam, and SDSS data, and if you have a camera that you want to be able to process using our system, we have a way to define, we have an API, thank you, Eric, to define the parameters of your camera, the properties of your camera, the properties of your filters, so that you can automatically process your data through our system once you've defined that.
What kind of API?
I'm not going to talk about it. It's well,
Python or web?
It's Python. Well, it's Python and C++. That doesn't matter, no. Right? No, Eric. We are an imaging survey, we are not a spectroscopic survey, so we don't have anything to deal with spectra, although that's kind of a lie. There are a couple of little things, but that's not the goal. So if you have imaging data you want to process in a uniform manner and get really good statistics out of, that's what we're here for. So what do we provide? We provide masked images, tables, coordinates, statistics, and I bring up statistics here because we have some tools that we don't think anybody else provides, like clipped mean over large images for stacking. And we have pipeline tasks. Process CCD is one of them, so that you can chain all of your tasks together, all of the things that you want to do, and have them all just go. The output from this one goes into this one, which goes into this one, and so on. A lot of these things look familiar to you because, for example, AstroPy provides them. LSST started development long before AstroPy. I'm not saying that makes us better. I'm just saying that's why we have things that exist in AstroPy. We have NumPy views into a lot of our things, so you can use them in a familiar way, but the API is not as familiar as it should be. And so that's, I'm going to get to that at the end. That's one of the points of a bunch of us being at this meeting, is to talk with AstroPy folks and see if we can make this a little more uniform. So these are things that we provide that you might be able to find something like that elsewhere. We also are or will be providing things that nobody else provides, or that other people are also actively working on. So we have a data butler, which provides abstract access to data. So you don't have to worry about, is the data in a FITS file or an HDF5 file, or does it live on that server in a database? You tell the data butler, I want this chunk of SDSS, and it gives you something with a uniform API where you don't care how it exists on disk. We are in the process of developing and implementing high-quality algorithms for what's called instrument signature removal. So when you build a CCD, there are certain defects embedded in how that CCD is built that matter if you want to say get weak lensing right? So we're building systems to actually remove those, but of course that means you have to know something about the CCD that you have. Detection and measurement, right? Doing detection of sources and measurement of sources is hard. There are tools that exist to do it, like Sextractor, but they are not optimal. Again, if you want to really get down to the sub 1% level. Co-addition and stacking and image differencing. I've already talked about those somewhat, but again, if you want to really take and stack all of your images, which may have been taken at different air masses, and so you have to worry about differential chromatic refraction, that's a hard problem. So we're in the process of developing really cutting edge algorithms to do all of these things. That's not to say you shouldn't use any of the other things, but hopefully we will be able to provide the best tools for this. A lot of these things don't exist yet, right? We're like instrument signature. Did Simon?
We have ISR.
We don't have.
Oh,
we don't have brighter fatter yet.
We have brighter fatter on the HSC side.
Right.
And we don't have tree ring.
Sure. So there's active development. So that's what we do. Here's where you can go to us: GitHub.com LSST, GitHub.com LSST DM. That's data management. So there are sub teams. There's a bunch of other teams. The dark energy people have a team. The SIMS group here at UW has a team. There's 241 repositories in the first one and 86 repositories in the second one. That's a big number. I'm not sure if saying 47 of those are external. That means a package we didn't develop, but we packaged it up so that our build system can manage it. I'm not sure if that makes it better or worse. There's about 250,000 lines of code, about half of which is Python. Is that half of which Python, correct? That doesn't count Swig. That number doubles if you count the wrapper that connects our C++ to our Python. Someone talked about extending, someone talked about extending Python, yes. So Swig is another way to extend Python so that you can connect it to other code. But we're on GitHub. Our code is open. We strive for good coding practices. Originally, this slide said we have good coding practices, and a bunch of people told me don't say that. We do. One of the big things that LSST I think does really well is that we do code reviews, and I'll talk about that in a second. The stack is Python and C++. It is legacy Python for now. Someone stole my thunder by using that earlier yesterday, but there's going to be a Python 3 conversion in August. we have a website where all of our developer documentation lives. This is relatively recent. This URL used to be a mess. But you can just go to developer.lsst.io to see it. All new code is reviewed before acceptance. That means, let's see, how did it go? Clone it, pull it, break it, fix it, branch it,
Oh, what was it?
branch it, commit, push it, pull request.
Something like
The Technologic song. The pull request step there cannot happen until someone else has reviewed the code. This is an explicit requirement of LSST, and this really helps catch things. It can be annoying, as some of us know, when you have this interesting thing and you want to push it, and someone's like, that breaks this other thing, and then you have to hash it out. But in the end, it makes everything better. And so this is something that I think any big group that has more than one person contributing to the code, you should do that. Also, as I learned, presentations are reviewed before acceptance, because as I was developing this, people were saying,
Truth in advertising. We strive to review presentations before.
And the more senior you are, the less review happens.
but the more senior you are has no impact on whether or not your code gets in, right? Senior people have their code reviewed and rejected. Well, not rejected, but changes have to be made before it's accepted. So we now have our coding style is now just a difference against PEP8. So actually, this is just a couple weeks old. We had a coding style guide, just like a lot of places do, like AstroPy does. But now you can actually go and just attach to your linter. Thank you for the linter presentation, Russell. It was perfectly timed. You can now just attach to your linter a little configuration which says, here's how to lint LSST code. We have a bunch of tests. We have quite a few unit tests. We need validation data sets. Those are being developed. So, right, if you want to do sub 1%, you have to have some truth that you can compare to.
About 3 more minutes.
Good, okay. And we automatically generate Doxygen documents, and we're in the process of converting this so we can use Sphinx. Sphinx and C++ didn't work together very well for a long time. So we have a continuous integration system. It's Jenkins. Sadly, Jenkins looks like a butler. That has nothing to do with the data butler. But every time you can, continuous integration. So every time as you're developing a pull request, it can get done. So there's a bunch of websites. I'm not going to talk about them much. We use HipChat internally for chatting. Community.lsst.org, I'll show you in a second. Tickets, we use Jira. The code review process is linked to GitHub. So when you have a ticket, it attaches to the GitHub pull request, and those things know about each other. You can't publicly submit tickets to Jira, but if you create a GitHub issue, the person who is responsible for it will go back and attach it, or tell you, actually, that's fine, do it this way, and then close it. And we have an RFC process, which is like the AstroPy EUPS. Just go to Jira and type RFC in the search box. So this is community. Anyone here can go and log in and be like, I was trying to use the stack and this thing didn't work. Someone help me. So this is our chat forum. Again, public. This is an example of Jira. This is actually it's perfect that Russell, so you heard me laughing really hard when Russell demoed LSST code in a linter. That's because of this, which just happened recently. So this is an example of an RFC. So we previously had a coding standard, and now that coding standard is going to become just like use PEP8 with the following changes, as opposed to this long document, which included a bunch of things pasted verbatim from PEP8. So there are ways to suggest to us improvements we can make. So here's what's going to happen starting vaguely late this afternoon and going through the weekend. Some of you are going skiing. A bunch of us are staying in this building and talking about how we connect AstroPy and LSST. So LSST is interested in how others in the community are dealing with some of the same problems we have, and we think we have some things we can provide to the community. So that's what we're talking about this weekend. One example, we use EUPS to control dependencies. When you're running a pipeline, you need to know exactly what versions of everything were live on the system when you ran that version of the pipeline. Because you have to know, when I ran it, can I reproduce it by running exactly the same thing? And can I do it somewhere else too? And we have this massive dependency chain. We have 241 packages that in GitHub that you need to control those things. So how do people manage that? How do you manage it in your analysis pipeline? How do you manage it in your build tools? Right. So I'm not asking for a slew of responses now, but let us know. This is the way that we do it makes it a little harder. Makes it harder for us to make LSST pip installable, for example. But it does what we need right now. So WCS. So this was what the original topic of this talk was going to be. The FITS WCS standard is wildly not sufficient for accurate distortion models. I think I have 2 slides left. It would be great if we could link up with AstroPy to provide precise distortion models and world coordinate systems. And we need to be able to persist or serialize, right, input-output that information. The FIT standard just doesn't provide a way to do that. I'm not asking for this to be solved today. This is the point of the meeting this weekend. There are essentially 2 tools available right now that do this well. PyAstro from Starlink and GWCS, which is currently under development. So, fork us on GitHub. Actually, please don't yet, maybe, because the API is still in flux because we're under very active development. So if you want to use this for your pipeline right now, you probably could, but in 6 months, everything will have changed. But so here's just a link dump for people to follow. These last 2 here, it's good that you're in the room. You may recognize these. Mario actually made a Conda package, so you can follow the instructions or just watch his video, his YouTube video, of how to get the LSST stack installed into Conda. Warning, it's about 1 gigabyte, so there's a lot of stuff. But you can Conda install it at least now. Thank you.
So will we only be able to install the entire stack as one package, or will it be possible to install separate
Are you asking now or in the future?
as soon as possible?
Right now, you can only install, there's so many dependencies, you have to install it all at once.
That's with Conda, but.
That's with Conda. That's with Conda.
Distro will let you install any subset.
You can install individual packages.
Oh, you can?
You
Okay.
can specify the package you care about. It will pull all the dependencies.
Okay, it will
if
take
you
all the
get to a
dependencies.
low level, it will just install that.
But if you want to install anything that you probably actually want to use, you'll get
You'll probably
basically
get most of
everything.
it, yeah.
There is discussion about making some of our tools into AstroPy affiliate packages that are somewhat separate. But that does not exist yet.
Adam,
Why is it a gigabyte? Is there a lot of data that is needed for?
There's a lot. Some of those dependencies include like really big matrix math libraries and the Swig stuff, and I mean Swig is I think the biggest part of it.
And we also build with debugging information turned
Right.
on to maximum. So we tried once with excluding debugging, stripping the binaries, it goes down by a factor of 10.
Oh,
But since the code is
because of that statement over there, we want debugging
Since the code
on.
is in development, we just keep it
could you briefly introduce yourself?
Oh, I'm sorry. I'm Mario Urich. I'm the subsystem lead for data management in LSST.
So our
Just to
framework
provide
class is 270 megabytes installed. So AFW.
So do you want to use mainly Conda for distributing the software, or are you looking at Linux package managers as well?
That's a good question. Yeah, everyone wants our problem solved so that they can use it. I think Conda at the moment is the way to go. Certainly having like Debian make an LSST suite of packages would be cool. He's the perfect person to have in the room for this particular discussion.
So one thing that we would like is we're internally using more and more Conda. We're using EUPS to install from source. But what we'd like is ultimately if we can get the community more engaged so that you have, us as the upstream provider of source code and then folks packaging in different build systems, that will be optimal because it's very difficult for us to support a whole variety of build systems that are out there. So Conda seems like a kind of good compromise.
This statement is critical, right? If you're doing a pipeline, you have to have version control and dependency management that's really robust. And so if anyone else is doing that, like, does AstroPy do any version control dependency management, or do you just sort of let that?
You mean
A given
Like-
version of AstroPy sometimes has specific.
Like, you must use numpy greater than equal to x, or specifically equal to x.
Never specifically equal, sometimes
Okay.
it's greater than or equal to.
So if you're doing a pipeline, you want to say specifically equal to. That's the trick.
So, last question from James.
So this code review that you say works well, does it really consist of one person reviewing another person's pull request, or is it like
Yes.
a group? Yeah.
Yeah, well, at least one person. It can be more. It often is more. It depends upon the size of the change, right? If you have 3 lines, you can say, I have a simple change. Could someone review it? And then either you specifically ask a person, like, Russell, do you have 5 minutes to review this? And Russell says yes, or Russell says no, and then you ask someone else.
It seems
Or
like,
you have a big thing, and you say, I have this big thing. Could someone review it? And then like 3 people might go and review it.
it seems like it ought to be
Something to
about.
add?
Oh, sorry. What were you going to say?
Oh no, it seems like it ought to be about optimal. We've sometimes had group code reviews with lots of people in, and it just drags out and takes away what we've done.
So, but this sounds like it's informal, taken care of
It's
by each other. You don't
Yeah,
have
I mean,
like a
we-
tagging system. and-
Yeah, no. I mean, you say, can you review this? And then in Jira, that person is the reviewer. And when that person says reviewed, you're good.
It's informal but mandatory.
Yes. Yes. Eric?
So do you do all of your code review on Jira in the open, or is the code review mostly closed?
The code review happens on GitHub, and it is open.
It also happens in Jira.
It also happens on Jira.
It can be a mix, but it's all open.
It's all open.
But you said that you need to have a code review before you are able to open the pull request, so you're not.
No, you open the pull request, and then the review happens on the pull request. But before you can merge the before you can merge the pull request, yes, the review.
And I actually wanted to say something about the 47 external packages. It's partly because some of them were very sensitive to which version is used, so we have to mandate a particular boost or a particular swig. Swig is by far the most fragile. Every time we try to upgrade swig, it's just another.
All right, let's thank John again.